I'm going to discuss class diagrams. The owner of the slides I use here is Dr. Timothy Lethbridge at the University of Ottawa. So if you go to this link, then you will find these slides. And first of all, I thank Dr. Timothy Lethbridge for granting me the permission to use his slides. Okay, so now before we discuss about class diagrams, okay, I assume you should have some basic understanding about object oriented programming in Java. Okay, so if you do not have any understanding, I recommend you to watch a playlist available in my YouTube channel. The name is the name of the playlist object oriented programming in Java. Okay, there are 8 videos. Then after watching those videos, you will have a very good understanding about the basics of object oriented programming. After you have gained that knowledge, then you can watch and understand this video series. Okay, now let's try to understand what is UML. Okay, UML, this is an abbreviation. Okay, unified modeling language. The unified modeling language is a standard graphical language for modeling object oriented software. Now you have some understanding about object oriented programming. If you want to develop object oriented software, then we draw a set of diagrams. Okay, the set of diagrams, we call it UML. Okay, unified modeling language. That is why we call this a graphical language, that is a set of diagrams. Okay, so if you look at the history, at the end of 1980s and the beginning of 1990s, actually object oriented paradigm appeared. Then after the invention of object oriented paradigm, then different people used different notations to model object oriented software. Okay, so now proliferation of methods and notations actually caused some confusion, especially when we communicate with each other. There are lot of confusion occurred. Therefore, around 1994, Rambo and Butch merged their approaches and they worked together in Rational Software Corporation. Okay, so and after that, in 1995, Jacobson joined this group. Actually, Jacobson focused on use cases. Use cases are also related to UML, but in this video I am not going to talk about use cases. Okay, and then in 1997, object management group standardized the process of UML. Okay, so actually that is the beginning of standard UML. Okay, that is a little bit about the history of UML. Now there are lot of UML diagrams. On my personal opinion, the most important diagram is the class diagram. Okay, so now I hope you know the difference between a class and an object. Okay, so class diagram means, for an example, let's think about an information system about a university. Okay, so if we want to design and develop an information system for a university, then first you have to draw a class diagram. Okay, so what are the classes you can find? You know, there are faculties. Faculty is a particular class. Okay, then each faculty has departments. Then department is a class, and in each department we have lecturers. Therefore lecturer is a class. Then especially we have students, most important class in our university system. Okay, then each department offer course units. So course unit is a particular class. Okay, likewise we can find many classes. Actually, identifying classes is also a complicated process. At the very beginning you feel it like a very simple thing, but when you watch this video series further, you will understand it is not a simple thing. Okay, so in this way you can identify classes, and in the class diagram you represent the classes as well as the relationships between among classes. For an example, now lecture some if you consider one particular lecturer, he is working in certain departments. If you consider a particular student, he or she is following several course units. Okay, and if you consider one particular department, it is attached to one particular faculty. Likewise, there are relationships between among these classes. Therefore, in the class diagram, we represent, we show classes as well as the relationships among them. So that is the purpose of class diagrams. Okay, class diagram. Now there are another type of diagrams. They are called interaction diagrams. Show the behavior of systems in terms of how objects interact with each other. That means, now if one particular student is going to add a particular course unit in a particular year, okay, so how this process, then the student interacts with the system and try to add that particular course. Then within the system certain process should occur. That process is modeled by interaction diagrams. For the time being, that understanding is enough. Later we discuss those diagrams in detail. Okay, so the other type of diagrams are the second type of diagrams, interaction diagrams. Okay, interaction diagrams. Then third point is state diagrams and activity diagrams. State diagrams and activity diagrams. Okay, so for an example, if a particular student want to perform certain calculation using the system, for an example, he or she press a button, calculate GPA. This is a button. Okay, GPA means grade point average. With universities, this one is very familiar. So if the student clicks on this button, then in order to perform the calculation inside the system, certain process should run. Okay, that process is modeled using activity diagrams, and also using state diagrams we can represent the different states of the system. Okay, for an example, if you consider a particular course unit, if we allow for a particular course unit we allow only maximum 100 students. Okay, so now that that particular object has two status. For an example, that means if the number of students are less than 100, registration is open for that particular object. If the number of students is 100, then registration is closed. Okay, likewise there are two states. So these things can be represented using state diagrams. And the last thing, they are component and deployment diagrams. So if you try to design and develop a small scale software, then the knowledge of these diagrams are enough. But if the system is big, then you have to divide the system into components, and component and deployment diagrams are essential to represent logical and physical organization of components. Okay, so in this particular video series we do not worry about component and deployment diagrams. Now let's look at some UML features. They have detailed semantics, okay, in order to represent detailed semantics are there, and also extension mechanisms are there. Extension mechanisms, that means UML diagrams are there to help us in the modeling process. We can extend them as we wish. Okay, there are no restrictions, and also there is a particular language, a textual language called object constraint language that can be used in our diagrams. In addition to the diagram, we can use this textual language in our diagrams, and these things we will discuss in this video series. And the objective of UML is to assist in software development, and also it is not a methodology. You are not going to follow UML. but there are set of diagrams, then you get help from those diagrams to simplify the modeling process. Okay. Now let's look at what constitutes a good model. Now we are talking about modeling. Okay. Here class diagrams means modeling with classes, something like that. Okay. So a model should use a standard notation. Okay. Use a standard notation because nowadays software development is usually done by teams, because huge softwares are built. Therefore, using a standard notation is essential. Okay, so everyone can understand and also be understandable by clients and users. These UML notations are simple so that even the clients and users also can understand them. And also the other thing, lead software engineers to have insights about the system. The software engineers can get a deep understanding using these models, and also they provide some abstraction. If you look at the class diagram, for an example, it provides some abstract view of our entire software. Okay, so and here models are used to help create designs, to design our software, to permit analysis and review those designs. Once you have design, then models can be used to review the design. And also, when you create a particular software, you have to provide the documentation for the users. In order to create that document, in order to compose that documentation, these models are very helpful. Then let's go to the next slide. Now we try to understand what are the essentials of UML class diagrams. The main symbols shown on class diagrams are classes, definitely classes. Now you know what are classes, and associations. For an example, now we have student class. Okay, we have student class and course unit class. Now we know there is an association between these two, because students follow course units. Okay, so let's say for the time being, using a line segment, let's represent the association, but later we want to discuss it in detail. They represent linkage between instances of classes. If you now we have already discussed at the beginning of this video, I told you that I recommended you a playlist, object oriented programming in Java. Okay, a playlist available in my YouTube channel. Okay, so if you have watched those videos, then the graphical notation of a particular class has three parts. For an example, if it is a student, the name of the class, and here we have attributes, registration number of the student, then name, gender. Likewise, there are many other attributes. This is the name of the class, and these are the set of attributes. And here we include display details. That is a particular operation. Okay, operation In my previous playlist, I have used the word methods for operations. Okay, here operations, that means in other words methods. Okay, in other words methods, display, calculate, GPA, those are methods. Likewise, now classes are there, then associations are there, attributes are there, operations are there. Then we have already discussed about generalizations as well. So using inheritance, we can group classes into inheritance hierarchies. This is the symbol. In this playlist, I have clearly discussed inheritance as well. Okay, now those are the basics. Now in order to draw a class diagram, you have to be familiar. Now let's go to the next slide. We talk about classes. A class is simply represented as a box with the name of the class inside. Okay, it is something like this, simplest form of representing a class. The diagram may also show the attributes and operations. That means this is the simplest form. This is the name of the class. One way is you can show only the name and operations. The other way you can show the name and attributes. And the third way you can show the name, set of attributes and set of operations. This is the third, this is the best way of representation. So sorry, okay, so this one we have discussed standard graphical notation of a class. We have rectangle, okay, rectangle, and the meaning of this one. Now if you have watched the playlist object oriented programming in Java playlist available in my YouTube channel, then you know these three notations. This one means private, this is an access modifier. Private, this is public, this is protected. If you do not specify any symbol, then that means default access modifier. Okay, so these things I have clearly discussed in this playlist. So I assume you have that knowledge. Now height, then int. The meaning of this one is, if you implement this one in Java, the access modifier is private, data type is int, variable name is height. Okay, in this way we can declare an attribute in Java. So graphically we represent it like this. In the same way we represent width of the rectangle int. Okay, so that means private int width. So we are going to represent a rectangle height and width. Okay, so these are the two attributes, and this one is public get area. The return type is int. Okay, now This one is something like this get area. The return type is public get area. We do not have any parameters. Then public return type is int get area. We have the body. This is the only thing we can get from here. So if you guess what is the purpose of this particular operation, get area means now this is a rectangle. This may return width into height. Okay, so this will return width into height. I have guessed the body. Okay, it is not mentioned in the graphical notation. And now this one resize. If you can remember the notation here, actually you have to put w int h int and return type void. Okay, that is missing in the slide. Okay, so you have to consider it should be corrected like this. Now this is the graphical notation, the complete graphical notation of rectangle class. Now if you look at the Java implementation of this resize operation, public yes, return type is void, public void resize int w int h. Okay, so here what we do, can you guess? Width into w. Okay, and height, we are going to resize the rectangle. Height means height into h. I have just guessed the body. Okay, it is not mentioned in the graphical notation. Okay, in this way we can represent classes. Okay, now in this slide I am going to talk about associations and multiplicity. Okay, so an association is used to show how two classes are related to each other. Symbols indicating multiplicity are shown at each end of the association. For an example, now let's look at the first one. So let's say in a particular company there are employees. So we have to create a class called employee. Now company, let's say this is an information system. We store details of companies as well as the employees work in those companies. So now you know there is an association between employee and company. Okay, so that means we can represent it like this using a line segment. Then it is something like this. If you put multiplicities here. Actually, this is one. The meaning of this one is actually some authors write down this one like this: 0, 2 dots, star. Okay, so some authors, instead of this one, some authors use this particular notation. Anyway, meaning of this one is 0 or more. Okay, meaning of this one is 0 or more. That means now you have employees. Let's say E1, E2, E3, E4, E5. These are the employee objects. Okay, E5, E6. And we have companies C1, C2, C3. Now the meaning of having one here means, if you consider one particular employee, he or she can work in exactly one company. That is the meaning of one here. Okay, if you consider any employee, he or she works in exactly one company. That means this employee in this particular company, this employee in this particular company, just an example. Okay, this employee, this particular company, this company. Okay, and this company. Okay, so this is not possible. Let's say since here we have one, this is not possible. Let's say we are going to connect in this way. Okay, then this particular employee is working in this company as well as this company. That is wrong. Exactly one company. Okay, therefore this kind of a situation is incorrect. Now this kind of a situation is also incorrect, because exactly one. Now if you have an employee who is not working in any of the companies, that is not possible. Every employee should work exactly in one company. Therefore let's say this employee is working here. Okay, now if you look at from employee side, one means if you consider any employee, he or she should work in exactly one company. Then if you look at from here we have 0 or more. That means if you consider one particular company, there can have 0 or more employees. Okay, so here there are 2 employees. Here also there are 2 employees. Here also there are 2 employees. If you consider this one, this is possible. Okay, since we have here 0 or more, that means there can have companies without employees. 0 is possible. Okay, here we have 0 or more. And let's say another employee is 7 working in this particular company. That is also possible. Now there are 3 employees working in this particular company. Okay, in that way you have to understand multiplicity. We put here in these 2 ends. Now again I mentioned here we have one means, if you consider any employee, he or she should work in exactly one particular company. And if you look at from this side, if you consider any company, there can have 0 or any number of employees. Okay, that is the meaning of the multiplicity. Now let's look at the next example. Administrative assistant. Okay, in a particular company or an institute. Okay, so we have manager. There may be many managers. That is why we have created a class like this. There are many administrative assistants. So we represent them using a class. And there is an association because with manager and administrative assistant. So here, let's say we have put 0 or more, and here 1 or more. That is a standard notation, 1, 2 dots and star. Okay. This one we could have written this one as 0, 2 dots, star as well. Okay. But in these slides, this notation is used. Now, let's say we have administrative assistants. Okay, and we have managers. Objects, these are objects. 6 administrative assistants are there, 3 managers are there. So if you look at from this side, here we have 1 or more. That means if you consider any administrative assistant, he or she can work for 1 or more managers. That means this one, let's say, works for this particular manager, and also this administrative assistant can work for another manager because 1 or more. Okay, so this one to this one, 1 or more, that is possible. This one to here, okay, that is also possible. This one to here, okay. This one to here, this one to here. Okay, in this way we can have. Now if you look at from here, if you consider any administrative assistant, he or she works 1 or more managers. 2, here 2 managers, 3 managers, 1 manager, 1 manager, 1 manager, 1 manager. Okay. So if you look at from this side, okay, any manager can have 0 or more. 0 or more administrative assistants. 2, 1, 2, 3, 4, 5. Okay. Then this kind of a manager is possible. 0 is possible. Therefore, there can have managers who do not have any administrative assistants. This one is correct. Okay. In that way, you have to understand multiplicity. Now, let's move to the next example. Now we have set of companies, so we represent them using company class, board of directors, here we have board of directors, and now each company has an association with the board of directors. Now here 1, here 1. let's say we have C1, C2, C3, C4. 4 companies, board of directors B1, B2, B3, B4. Okay. So, if you consider one particular company, it should have exactly one board of directors. So, this one here, 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 here. Okay. If you consider any company, exactly one board of directors, exactly one board of directors, exactly one board of directors, and exactly one board of directors. So here we have one. If you look at board of directors, uh, they are associated with exactly one company. So here exactly one, exactly one, here exactly one, exactly one. So is it possible B5, B5, is it possible with this board of directors? No particular company. This is wrong. Okay, there should be exactly one company. Let's say here if we have C5, this is not possible because for each company we should have exactly one board of directors. So here we do not have a board of directors and therefore this is wrong. Okay, now let's look at the next example. Office and employee. There is an association. Office room, actually the meaning of office means an office room. 001. Okay, 001. Here we have 0 more. That means let's say we have office 1, office 2, office 3, then employee 1, employee 2, employee 3, employee 4, employee 5, employee 6. Okay, in this way we have 3 office rooms and let's say we have 6 employees. According to this one particular office room can have 0 or more employees. That means let's say in this office room we have these employees. Okay, in this office room we have these employees. Okay, now this is possible, an office with no employees. It is possible because here we have 0 or more. 0 is there, therefore this is possible, this is correct. So if you look at from here, any employee has an office or at most one office. 0 or 1 office. Okay, so this is possible. E7, this employee does not have an office room. Okay, this is possible, but can this be possible? If you draw this, this particular employee has 2 office rooms. This is wrong. Okay, this is wrong because here at most 1, 0 or 1. Okay, therefore this one is incorrect. Okay, this one is incorrect. Okay, in that way you have to understand multiplicities. Now let's look at the next one, person okay, there are many persons, okay, person objects, okay, then here board of directors. Now this is a class. Now there is an association. Let's say we have an association here, 0 or more. Now persons P1, P2, P3, P4, P5, P6, P7, P8, P9. Okay, likewise we have persons, then board of directors B1, B2, B3. Okay, let's say we have it like this. Then here 0, 3 to 8. The meaning of this one is, if you consider one particular board of directors, there can have board of directors without any persons. That is possible, okay? And then 0 with 0 people, board of directors with 0 people. That is possible according to this particular diagram, okay? So then exactly 3 is possible. 3, 4, 5, yes, 5, 6, 7, 7, 8. Okay, those are the numbers possible with one particular board of directors. That means here 0 or more means one person can work for 0 or more board of directors. Okay, this person can work in this board of directors as well as this board of directors as well as this board of directors, and this person can stay without working for any board of directors because 0 is possible here. Okay, now if you look at this, let's say this person works for this board of directors as well as this board of directors. Okay, and now let's look at here. This is not possible because 2 is not possible. Okay, therefore this is wrong. Okay, therefore we need at least 3. Okay, 3. Now this is okay. Okay, this is also not okay because 2 is not possible. Let's say this one and this one. Okay, and now this one is possible because 0 persons, board of directors with 0 persons is possible. Okay, therefore B4, this one is possible, and these are also possible. There can have persons in our information system without involving in board of directors. Okay, so okay, now I hope now you got a very good understanding about associations as well as multiplicities. Then we discuss how to label associations. Now class diagram means you have classes, then relationships. Relationships can be represented either as generalizations or associations. Okay, now here we discuss how to labeling associations. So here let's look at the first example, employee, company. Now multiplicities we have already discussed. Let's say here 0 or more, here 1. Then what is the association between employee and company? We can write it here. Work for. On the middle of the association line, we can write the type of association. Okay, then this is called the label. Okay, label of the association. Then let's move to the next one. Administrative assistant, manager, multiplicities we have already discussed, 0 or more, 1 or more. Okay, and here we can put the role. Now in earlier situation I have told you how to put the label, put a label for an association. Then the other one is role. Role means if you look from the side of an administrative assistant, manager is his or her supervisor. Therefore, in this end, you can represent supervisor. Okay, this is called the role. Role. Okay. Now, in the third example, no label or role is shown. Okay, that means it is not essential to put a role or roles or labels. Okay, so we have to put whether when it is essential. And now if you look at this one, fourth one, if you look at an office, okay, office, then employee, here we have, in one particular office room there can have 0 or more employees, and one particular employee can have no officers or at most one office. Okay, so here the name, the label of the association is allocated to any suitable, and we specify from an arrow. That means an office is allocated to particular employee. Okay, employee or employees. Okay, so in here the label we have to put a suitable name. Okay, office reserved for, or any suitable name we have to put. Okay, now let's look at the next one. Person, here we have board of directors, and this is the association. Person can be in 0 or more board of directors, and here one particular board of directors can have either 0 persons, 3, 4, 5, 6, 7 or 8. Okay, that is the meaning. And here we can specify from the board of directors side a person is a board member. Okay, here we can specify the role of person. Okay, board member. Okay, that is how we put labels and roles for associations. Now let's move to the next slide. Analyzing and validating associations. Now many to one. Many to one. That means if we look at this particular diagram, employee, our employee class, then our company class. Okay, there is an association. We know employees works for. Okay. Then first line says a company has many employees. Okay, so therefore has many employees. Now here we try to discuss how we can understand multiplicities, how to put multiplicities. First line says a company has many employees. That means we do not know from this here what to put. Many employees means it can be 0 or more, or else 5 or more. Okay, so still we do not know how to get an idea what to put here. Okay, then an employee can only work for one company. Okay, employee can work for only one company. That means 1, 0 or 1. We do not know this one or this one. Okay, an employee can work for one company, or we do not know, many companies possible. Okay, we do not know. It says just an employee can work for one company, not only one company. Okay, so this company will not store data about moonlighting activities of employees. That means this company, we do not store unofficial work of employees. Okay, so this line says a company can have 0 employees. So that means 0 is possible. 0 is possible. For an example, shell company. There are companies without any employees. That is possible. Okay. Fourth line says it is not possible to be an employee unless you work for a company. Okay, so unless you work for a particular company, you cannot be an employee. Therefore, this is not possible. Okay, 0 is not possible. An employee should work at least one company. Okay, here, yes, here it says only work for one company. Okay, so this is not possible. Okay, only work for one company. From these two, what to select? From the last line, we could understand we have to select this one. Okay. So here we can put 1, and here a company can have 0 employees, therefore 0 is possible, and it says many employees, therefore we can understand 0 or more should come here. Okay. So depending on this information, you can put here 0 or more. Okay, that is the multiplicity you can put there. And now let's move to the next one. So here we have assistant. Okay, here we have manager. There is an association. An assistant can work for many managers. Okay, we do not know this one. Okay, for the time being 0 or more managers. Okay. A manager can have many assistants. We do not know here what to put. Let's for the time being many, 0 or more. Okay. And assistants can work in pools. Okay. That means one particular assistant can work for more than one manager. Okay. Managers can have a group of assistants. If you look at a manager, several assistants they can get. 0 or more is still. Okay. Some managers might have 0 assistants. Therefore, we finalize this one as the correct one. Okay. Then it says, is it possible for an assistant to have perhaps 0 managers? Okay. For this question, if the answer is no, okay, then if the answer is no, we have to put 1 or more. Okay, that means there should be at least one manager for a particular assistant. Therefore, if the answer for the last question is no, is it possible for an assistant to have perhaps temporarily 0 managers? If not, it should be the many managers. No, it should be 1 or more. 1 or more. Okay. And now here we can put many assistants, and some managers might have 0 assistants. Therefore, here we put 0 or more, and we can put a role here, supervisor. The role of the manager is the supervisor of the assistant. From this side, when an assistant sees the manager, he or she sees the manager as the supervisor. Okay, that is why we put the role here. Okay. Now let's move to the next slide. Before that, this one is many to many. Many to many. Many to many association. Okay. Now okay, then we talk about this one, company and board of directors, let's say we have an association between these two. For each company there is exactly one board of directors. That means for one particular company there is exactly one board of directors, and a board is the board of only one company. Okay, for each company there is exactly one board of directors. A board is the board of only one company. One board, only one company. Okay, so we have already decided a company must always have a board. If you consider a particular company, always it must have a board. Okay, therefore 0 or 1 is not possible. This is not possible. Must have a board. Okay, a board must always be some company. And if you consider board of directors, it should associate to one company always. Therefore, in this situation also 0 or 1 is not possible. Okay. Now let's move to the next slide. Okay. Now when we talk about associations, this is one particular example. Here, if you consider person, you can get class, no? Person and person info. This is another class. Now we can have a one-to-one association here, because for one particular person there is exactly one person information. For one particular person information related to exactly one person, we can put it like this, and here we put the name and here we specify rest of the attributes. But we do not recommend this kind of associations. Okay, when we put associations in the class diagram, we have to be careful. This is not suitable. Okay, now you have to think, this is unnecessary thing. You have to logically use your common sense and think, this is an unnecessary thing. Why we put two classes and connect them using an association? So better way is to use this one. This is better than using this one. This one is better. Okay, now let's move to the next slide. Now we talk about a more complex example. Now a booking is always, in this particular slide we talk about an airline reservation system. Okay, so we have a passenger class. Okay, booking, and here is specific flight. Okay, passenger and bookings, there is an association. Booking and specific flight, there is an association. The meaning of this one is no booking with 0 passengers. A booking could never involve more than one passenger. A passenger can have any number of bookings. A passenger could have no bookings at all. A passenger could have more than one booking. Okay, it is something like this. Now let's say we have passengers P1, P2, P3, P4, P5. Then we have specific flights S3, S4, S5. Okay, so X5, P5, P6, P7, something like this. Okay, now bookings here. If you consider now one particular object from the booking class, this particular booking is done by this particular passenger. Okay, so for this booking, for this particular booking is done by this particular passenger. Okay, and this particular flight. Okay, this passenger books this particular flight. Okay, no booking with 0 passengers. Now for one particular booking there can have several passengers. Okay, see, with 0 passengers a booking is not possible. A booking could never involve more than one passenger. One booking, it should involve not more than one passenger, because in flights one particular passenger books the flight. Okay, so one particular passenger books the flight. A passenger can have any number of bookings. That means this passenger another booking, this one. Anyway, one particular booking involves exactly one passenger. Okay, if you put something like this, this is wrong, because this booking involves then more than one passenger. Okay, this is wrong. A passenger could have more than one booking. Yes, one passenger can do more than one booking. A passenger could have no bookings at all. Okay, this is possible. This passenger does not have any bookings. Okay, so this one B3, this one. Okay, likewise B4. Okay, in this way. Now let's see here, if you have 0 or more, that means one passenger can do 0 or more bookings. This is possible. 2, here 0, here 1, here 0, 0, here 1, here 0. Okay, so this is now okay. Understood? Now here 1 means if you consider one particular booking, it involves exactly one passenger. This one exactly one passenger, this one exactly one passenger, this one exactly one passenger, and this one exactly one passenger. Okay, so here 1 means a booking involves exactly one specific flight, one particular booking, exactly one, exactly one, exactly one, and exactly one. Okay, so here 0 or more. Zero or more bookings. Here 0 or more means, now if you consider one specific flight, it can have either 0 or more bookings. Now here there are 0 bookings. This is possible because here we have 0 or more. Okay, this is possible. In that way you have to understand, and the frame around this diagram is an optional feature that UML 2.0 may possess. Okay, just like Windows 7, Windows 8, Windows 8.1, Windows 10, in UML also it has some evolution. Now we have in here we discuss UML 2.0. Okay, there they have introduced this kind of a frame, booking passengers on flights. So we can put a label to this particular part of the class diagram. Okay, and now let's move to the next slide. Then here we talk about association classes. Sometimes an attribute that concerns two associated classes cannot be placed in either of the classes. Let's say we have a student class and course section, a particular course unit, let's say. Okay, course section, there is an association. Okay, now 0 or more, 0 or more. Okay, that means there are students S1, S2, S3, S4, S5. Now course sections, course 1, course 2, course 3, let's say there are 3 course sections and 0 or more course sections. That means this particular student 1, 2 course sections. This student has added 2 course sections. This particular student only 1 course section. This student 1, let's say, yes. Is this possible? If you consider this particular student 0 or more course sections, okay, 2, it's okay. 0 or more course sections, this is okay. 0 or more course sections, this one is okay. This one is okay. This one is okay because 0 is possible. Okay. Now if you look at this one, this particular course section involves 2 students. This one 1 student. This one 3 students. That means 0 or more students. Now C4, this is also possible because 0 is possible here. Okay, 0 is possible. Now let's say, now after particular student registers for a particular course, and after for the examination they earns a particular grade. Okay, this is student, this particular student earns a particular grade for course section, this course section, and also this course section. Then there are two values, no? Two values. So whether we put it here or here. Okay. So one way is we can put the number of we can put the course sections, the grades in this particular, in student object we can store grades in an array or a list. Okay, that is one particular way of doing that. Okay, so in the course section here there can have many number of students. So using an array or a list we can store the grades of the students. But if you do it in that way, okay, let's say in an array or a list we store the grades of the students, but then we store the grades. Okay, now we do not have a way to which student this grade corresponds. Okay, to which student this grade corresponds. Okay, likewise the process now becomes complicated. So always we try to model in a better way. Okay, that is modeling. Okay, we try to make our models as simpler as possible. Therefore, rather than doing it in this way, it's better you put the grade in a separate class. Let's say registration class. Okay, so here we put the grade and we have an association like this. Okay, so that means for each link we have a registration object. That means for this particular link we have R1. Let's say R1, R2, R3, R4, R5, R6, R7. Oh, sorry. I have put R3, R4, yes, this one, 5, 6, okay. R5, R6, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, likewise, with each link we associate with registration object. Okay, now in this particular object, now this particular student, after sitting the examination of C1 course section, earns a particular grade. That grade is stored in the grade attribute of R1 object. Okay, so these are called association classes. And as in previous example about airline reservation system, here the equivalent notation is this one. Okay, for this one we can draw this one alternatively. Student, okay, then here we have registration, and here we put the grade. Okay, and now here we have course section now here now you can see if we consider any registration, okay, any registration object, here 1, here 1, okay, any registration object associated with one particular student object as well as one particular course section object, okay. So here we have 1 and 1. If you consider one particular student, he or she involves with several registrations. Here we have 2, okay, and this student no registrations, therefore 0 or more is here. If you look at this one in course section with this one, that means 0 or more, because here we have 0 or more. In this way also we can represent. And now let's move to the next slide. Here we talk about reflexive associations. It is possible for an association to connect a class to itself. For an example, if you consider course class, okay, so here this is an association, it connects to itself. Let's say here 0 or more, 0 or more. This is the multiplicity. And now you know, in order to follow this particular course, UML course, okay. So I told you that you need double OP knowledge at the beginning of this video, okay. So for this one, this course is a prerequisite, okay, prerequisite, okay, prerequisite. Let's put the arrow in this direction. So in order to follow this course, you should have followed this one, okay. That means for this particular course, this one is a prerequisite. And on the other way around, we call this one as a successor of this course. Once you have followed this course, then definitely you can follow this one, okay. So here labels, putting both ends in the presentation, in both ends we have successor and prerequisite, but putting at one end is enough, okay, prerequisite. That means if you consider one particular course, there can have 0, if you consider one particular course, there can have 0 or more prerequisite courses, okay. If you consider one particular course, okay, there can have 0 or more prerequisite courses, okay, 0 or more prerequisite courses for a given course. And if you have one particular course, we can follow 0 or more successor courses, okay. In that way, this is how we represent that kind of an association. This is called a reflexive association, okay. Course objects are associated with course objects, okay. And another example for this one is in this way. The label is mutually exclusive with. That means if you consider two courses, if we do not have anything in common, we say that these two causes are mutually exclusive. So if you consider pair of causes from the causes available in the university, if you can consider any pair, okay, we can find any pair, or if you consider one particular cause, then we can find 0 or more causes which are mutually exclusive, which has mutually exclusive content with this particular cause. Okay, so those are called reflexive associations. And the next one is directionality. That directionality in associations are by default bidirectional. That means with two classes, if you put in this way actually, here this is actually something like this, combination of these two. Okay, combination of these two. Here we write it in this way. In other way, this one we could have written in this way as well. Okay, but for simplicity we draw it like this. That means the associations we have discussed so far, they are bidirectional. That means if you consider an object from this particular class, there is a link to, okay, so if you consider one particular object from this class, there is a link to the corresponding object from this class. Okay, and if you consider an object from this class, it has a link to an object in this particular class. Okay, bidirectional. In this way we represent that if we consider an object from this particular class, it has a link to the associated object in this particular class. Okay, in this direction we represent, the other part in this direction we represent. Okay, so unidirectional associations are also there. It is possible to limit the direction of an association by adding an arrow at one end. Okay, so if we need to have a unidirectional association, okay, we put an arrow and specify it, day and not. This one, 1 or 0 or more. That means if you consider, let's say D1, D2, D3, D4, not 1, not 2, not 3, not 4, not 5, not 6. Okay, so unidirectional means, now let's say 0 or more, 0 or more nodes. For the day 2, 0 or more nodes. 0 is possible, therefore this is okay. Now here any node is associated with exactly one day. Yes, 1, 1, 1, 1, 1, 1. Okay, N7, this is not possible because exactly 1 here. Now unidirectional, the meaning of unidirectional is if you consider any object, okay, if you consider any object, we have a way to access its corresponding object. That means here we have a reference variable that stores these objects, this one, this one and this one. In this way we can represent even in this diagram. Okay, but if you consider this particular object, we do not have a reference in this object to this one. Okay, so it is unidirectional. Here also in the same way these links are unidirectional. Okay, that is the directionality of associations. Okay, now if you move to the next slide, it's about generalization. Okay, and now in our class diagrams part 1, okay, this is the end of the video. Class diagrams 1, okay, we have discussed 1 to 17 slides. In the next video, class diagrams 2, we will continue from 18 slide onwards. Okay, so and if you could understand what I have discussed, so please, I have a request, you can subscribe my YouTube channel. Okay, and also if you have any questions, you can put comments in the comment section. If you have any questions, you can mention there, I will answer. Okay, and also finally I again thank Dr. Timothy Lethbridge for granting me the permission to use these slides to create YouTube videos. And for you, thank you for watching the video.